In last video, we learned about what is meant by chemical reactions and different types of chemical reactions. Now in this video, we are going to see what is meant by chemical equations, how to write that and how to balance that. Chemical equations. What is meant by chemical equations? We know that what is meant by chemical reactions. But how to represent that and how to write that, we'll see in this part. Expression of chemical reaction is known as chemical equations. The form in which we are writing the chemical reaction, that is known as chemical equations. The description of a chemical reaction can be written in a shorter form. The simplest way is word equation. When we are writing chemical equation in the form of words, we are using word to write a chemical equation, then we are saying that is a word equation. For example, see, magnesium when react with oxygen, it gives a magnesium oxide. We are writing this chemical reaction in the form of words. We are not using symbol here. Magnesium plus oxygen, it gives magnesium oxide. Like that we are writing reactants and products. Then this form of equation is known as word equation. But every time it is not easy to write in the form of word if the chemical reaction is very lengthy. That's why we are using for our convenience some symbols to write those chemical reactions. Now, how to decide these symbols? What are the symbols of different element and compounds? That we already learned in the 9th standard. And by using those symbols of elements and compounds, we can easily able to write the chemical reaction in the form of chemical equation in short form. The short form of chemical equation, by using the symbol, it is easy to write as well as easy to understand. The reactants are written on left hand side with plus sign between them, and products are written on the right hand side with a plus sign between them. The arrowhead points towards the product and shows the direction of the reaction. In any chemical reaction, when we are writing the chemical equation, we are writing always reactant at the left hand side, that is magnesium and oxygen are reactant, that's why we are writing those at left hand side. And the magnesium oxide is a product in this reaction, that's why written here on right hand side. Now this arrow which we are drawing in between the reactant and product, it indicates the direction of chemical reaction. And in this way, by using these rules, reactants at left hand side, products at right hand, and in between arrow, and when we are writing this chemical in word, then we are saying this whole form is of word equation. The expression of chemical reaction is known as what? Chemical equation. Now we'll see how to write a chemical equation. Chemical equations can be simplified by using chemical formula. A chemical equation represents a chemical reaction. Yes, we learned that the chemical equation represents the chemical reaction. Or to represent the chemical reaction, we are using chemical equation. Chemical equation can be simplified by using chemical formula. There are some formulas, there are some symbols we are using to represent the element as well as compounds. And by using those symbols, by using those formula of compound, what we are doing? We are able to write the chemical equations. Just the above equation which we wrote in a word equation form, how to write this in a symbolic form, we'll see. The symbol of magnesium is Mg, symbol of oxygen is O, and magnesium and oxygen when react with each other, it gives a magnesium oxide, and that's why the formula of magnesium oxide is Mg. The chemical reaction, when we are writing in the form of chemical formulae, then we are saying that is a skeletal chemical equation. If the number of atoms of each element is not same on left hand side and right hand side, the equation is unbalanced. It is called a skeletal chemical equation. If same, it is balanced. For example, what? Here, the number of magnesium and oxygen on both sides, left hand side and right hand side, we need to check whether they are same or not. If they are same, then no need to equalize. But if the number of reactants and the number of products or the atoms which are present at reactant and the atoms which are present at product side are not same, then we need to equalize that. When the number of atoms are not similar on both the sides, reactant and product, that time that type of reaction is known as skeletal chemical equation. For example, in this reaction, magnesium is same, but the number of oxygen atoms are not same on both the sides. That's why we are saying this is the skeletal chemical equation. When the number of atoms on both the sides are not similar, then we are saying that is a skeletal chemical equation. But when the number of all the atoms on both the sides are same, then we are saying that is the example of balanced chemical equation. Now we'll see with the help of example. Here, magnesium plus O2 gives magnesium oxide. In this reaction, both the number of magnesium and oxygen are not similar on the both the side. For example, here at LHS magnesium is 1. Here at RHS also magnesium is 1. But oxygen number here at LHS 2 and at RHS 1. That's why we are saying this is the example of skeletal chemical equation. And this is known as balanced chemical equation by Wilson. Here at the LHS also the number of magnesium is 2 and RHS also 2. Number of oxygen is 2 atoms and here number of oxygens are also 2. That's why on both the sides the number of all the atoms are similar. So we are saying this is the example of balanced chemical equation. Simply you can remember the equation or the chemical equation which is unbalanced, that is known as skeletal chemical equation, and which is balanced, that is known as balanced chemical equation. What is meant by skeletal equation? What is meant by balanced equation? And what is meant by unbalanced equation that we just learned? But why need to balance those chemical equation? We'll see now. According to the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. Total mass of the elements present in the products is equal to the total mass of the elements in the reactants. According to the law of conservation of mass, the mass of the product is always equal to the mass of reactant. That's why we are going to balance the chemical equation, because the number of elements are always equal in product as that of the reactant. They can neither be reduced, they can neither be increased. The number of atoms of each element remain the same before and after a chemical reaction. So skeletal chemical equation must be balanced. Skeletal chemical equation, which is unbalanced chemical equation, and we are balancing according to the law of conservation of mass. What tells this law? Mass of product is always equal to the mass of reactants in any chemical reaction. So that we need to balance that chemical equation. Now how to balance that? We'll see with the help of example that word equation of a chemical reaction. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. This is known as word equation because we are writing in the form of word. It is represented by the following equation in the form of symbols and formula we'll see. That is zinc plus H2SO4 gives zinc sulfate plus hydrogen. But in this reaction we need to check whether all the number of atoms are similar on both the sides or not. If not similar, then we are saying that is unbalanced reaction or skeletal equation, and if it is not equal, not balanced, then we need to balance that according to the law of conservation of mass. Now we'll check whether those both the sides are same or not. Here in this chart what is given, we'll see. We need to make this chart. We need to make the chart like this to balance the chemical equation. Elements, first which type of elements and how many elements are present in that chemical reaction, we need to write those here. And then number of atoms in reactants and number of atoms in products. See, zinc at reactants, how many zincs are there? Only one. And at product side is also one. Hydrogen, how many hydrogen atoms? 2 hydrogen at LHS and 2 hydrogen at RHS. Now see third, that is sulfur. How many sulfurs at both the sides? Both the sides sulfur is 1 1. And last, that is oxygen. They are also 4 4 on both the sides. Means all the number of atoms are similar on both the sides, left hand side as well as right hand side. That's why this chemical equation is known as what? Balanced chemical equation. Now all the numbers are similar, that's why no need to balance this chemical equation. But if all the number of atoms are not similar on both the sides, then we need to balance that. But how to balance that, we'll see next. That is steps of balancing a chemical equation. Hit and trial method, balancing a chemical equation using least whole number coefficient. Fe plus H2O gives Fe3O4 plus H2. Now first we need to check how many number of atoms on both the sides. Iron, that is ferric ion, are here at LHS1 and here 3. Note down first those numbers. Then hydrogen, here 2, LHS side also 2, and at RHS also it is 2. Then see oxygen, number of oxygen atoms at LHS1 and at RHS there are 4 number of oxygen atoms. Number of ferric atom and oxygen atoms are different on both the sides. The first step to balance the chemical equation is draw boxes around each formula. Do not change anything inside the boxes. Write down as it is the number of those atoms, like this one. Next step to balance the chemical equation, that is select the compound, reactant or product having maximum number of atoms. In that, select the element having maximum number of atoms. Now see, first we need to select the compound in which maximum number of atoms are there. After that, we need to find out maximum number of atoms in that compound. For example, now in that chemical reaction Fe3O4 is a big compound, and in that number of atoms are more that of oxygen, and that's why first we are taking oxygen here. First we need to find out the big compound, and from that we need to find out whose number of atoms are more. Now in this reaction Fe3O4 is bigger compound, and in that number of oxygens are more. That's why we are taking oxygen here. Initially number of oxygen atoms are 1 at LHS and 4 at RHS. Now after balancing, we need to make them same. That's why what we are doing? We are doing multiplication of this reactant side by 4. Then only we are able to equal those both the sides. That's why what we are doing, multiplying by 4 to RHS. After multiplying to this H2O, what we are doing, 4 oxygen atoms we get, but the number of hydrogen also increases, because what we are doing, 4 2s are 8 hydrogen atoms are there. Now hydrogen atoms are imbalanced here. We need to count each and every atom after every step. Here number of hydrogens are 8 at LHS and number of hydrogens are 2 here at RHS. So we'll see next step. In fourth step, balance the number of hydrogen atoms. Initially, 8 number of hydrogen atoms are at LHS and 2 at RHS. To make them equalize, we need to multiply the RHS by 4. That's why 2 into 4 we are doing here. Then we'll get 8 hydrogen on both the sides. So we are doing the same here. Fe plus 4H2O gives Fe3O4 and multiplying this hydrogen by 4. That's why we get 4 hydrogen here. Now in next step, that is fifth step, balance the number of iron atoms. Atom of iron, that is initially 1 in reactant side and 3 at product side. To make both sides equal, we need to multiply by 3 to reactant side. That's why we are multiplying this Fe by 3. Then we get 3 iron atoms on both the sides, 8 hydrogen atoms on both the sides and 4 oxygen atoms on both the sides. At the end, you can once again check the number of atoms, whether they are equal on both the sides or not. Steps of balancing a chemical equation. Count atoms of each element on both sides of the equation to check the correctness. For checking, we need to count once again all the numbers of atoms on both the sides, right hand side as well as left hand side. We'll see. Here 3 iron atoms, here also at right hand side 3 iron atoms. 8 hydrogen atoms on here LHS as well as 8 hydrogen atom at RHS. Oxygen also 4 atoms at LHS and 4 atoms at RHS. Means both the sides are equal, both the sides are balanced. Then we are saying this is the balance equation which fulfill the law of conservation of mass. Now step 7. If necessary, physical states such as gaseous, liquid, aqueous and solid states are included in a chemical equation. Now see, when we are writing any chemical equation, we need to know that chemical is in which form, in which state. To understand that, we need to write the state of that chemical in the bracket. For showing the state of matter, we are using some symbols. If that chemical is in a solid state, we are using S to show the state of that matter or chemical. If that is in liquid form, we are using small l to show the liquid state. If it is in aqueous form, we are using AQ to represent that aqueous form. If it is in gaseous form, then we are using G to represent its gaseous state. We'll see with the help of example how to write the states of these different chemicals in a chemical equation. 3Fe, that iron is in solid state, that's why in bracket we are writing S. Here in 4H2O, H2O is in gaseous form, that's why in bracket we are writing here G. Fe3O4, which is in a solid form, that's why in bracket written here S. And H2, that is in a gaseous form, that's why written here in a symbol, that is G. Aqueous, AQ means the reactant or product is present as a solution in water. When any reactant or product is present in a solution of water, then we are using aqueous symbol for that state. H2O, G indicates that water is used in the form of steam. Generally water is in the form of liquid form, but if it is in a steam form, then we are using gaseous symbol for water. In this way, we are using different letters, different symbols to represent the state of those chemicals, to represent chemical equation. Sometimes some conditions are required to complete the chemical reaction, and To represent those conditions, we are writing those conditions along the arrow in a chemical equation. How to write that, where to write that, we'll see. Sometimes reaction conditions, that is temperature, pressure, catalyst, are indicated above and or below the arrow in the equation. How much temperature, how much pressure, how much catalyst or which catalyst we are using for chemical reaction, that we are writing along the arrow. For example, here in this reaction carbon monoxide is in gaseous state, that's why written in G. Hydrogen is in G form and it gives CH3OH which is in a liquid form. But to complete this reaction, we require how much pressure? 340 atmospheric pressure we require, and that's why we are writing that pressure on the arrow. In second reaction, we'll see 6 CO2 which is in aqueous form and 12 H2O which is in liquid form. They both react with each other in the presence of sunlight and chlorophyll. Now here, the substances which are required to complete the chemical reaction, we need to represent those also in a chemical reaction, which is very important. In this reaction, this is a photosynthesis reaction. Sunlight and chlorophyll both are very important. If we are not writing those along the arrow, then this reaction is incomplete. That's why we should need to write these things along the arrow. Now this CO2 and H2O react with each other in the presence of sunlight and chlorophyll. It gives a glucose, oxygen and water. Now in this reaction everything is represented, that is state of chemicals, all the chemicals is written. Conditions of chemical reactions are written here. Symbols are also used, and this is the correct representation of chemical equation. In this way, in this part we learn about what is meant by chemical equation, how to write a chemical equation, how to balance a chemical equation, and why need to balance a chemical equation.